Welcome to Science Corner Tutorials. We'll be looking at science concepts in depth. Get ready. Let's get started. Now that we have done the previous videos, introductory videos on proof of identities, laying the basic foundation for us to be able to use standard identities in solving different problems or proving different identities, it is prudent that we might start now to put into effect the information that we have acquired. So the questions will just come and say, prove the following identities, right? So this is an example. It's saying cos sec A minus sine of A is equal to cos of A cot of A. So when proving identities, it's entirely up to you. It's your own decision whether you want to work from the left hand side going to the right hand side, or you want to do it the other way around. That is what we mean here by saying you can choose to move from either direction. It doesn't really matter, but ideally, you're supposed to be moving from the right hand side going to the left hand side. So you're supposed to prove that the right hand side here will give you what is on the left hand side. So that is what I'll be doing as we'll be going through different examples. So I'll be moving from the right hand side going to the left hand side. And say I'll be moving in this direction. So we've got the question that was saying cos sec of A minus sine of A as our question here. Now, remember that cos sec is similar to 1 over sine. So this is where now the application part comes into play. You've got to know what is the standard identity of cos sec. So cos sec is similar to 1 over sine of A minus sine of A, right? Then from there, remember that on the left hand side, we've got a single entity here. So you make sure that the right hand side, you're also going to make it a single entity, right? So from there, you're going to simplify it. Your common denominator is sine of A. And ultimately, you're going to get 1 minus sine of A, sine of A. So sine of A multiplied by sine of A, you're going to get rid of sine squared of A, which is here. So it's 1 minus sine squared A over sine of A. So you've got to keep in mind now that you on the left hand side, you're supposed to prove that this here, right, is supposed ultimately to give you this, right? So how then can you end up with cos of A, cot of A from 1 minus sine squared of A, right? So remember on the cos of A, cot of A, right, is similar to cos of A over sine of A. So this and this are just similar. So 1 minus sine squared of A, if you want to end up with cos of A multiplied by cos of A over sine of A, you're supposed to change sine into cos because on the numerator you've got cos. So 1 minus sine squared A, remember the standard identity is cos squared theta plus sine squared theta is equal to 1. So you are going to make cos the subject of the formula. So it's cos squared theta is equal to 1 minus sine squared theta, which is similar to what we have here. 1 minus sine squared A is similar to cos squared A. So you can substitute cos squared A over sine A. Then cos squared A is equal to cos of A multiplied by cos of A over sine of A, right? So if you put a bracket here, you're going to have cos of A over sine of A multiplied by cos of A. But cos of A over sine of A is an identity, is equal, similar to cot of A. Then cos of A, you have got cos of A as it is. So it means that you have proven that the right hand side is similar to the left hand side. So that's how you basically prove identities. So let's look at another example. The second example here is saying sec squared x plus cos sec squared x is equal to cos sec squared x sec squared x. So you're supposed to prove this identity. So I would urge you first of all to convert, into simpler either sine or tan forms, right? Either cos, sine, or tan, right? Remove it from the cot or the sec, it might confuse you. So moving from the right hand side, the left hand side, sec squared x is similar to 1 over cos squared x using our standard identities. Plus cos sec squared x is similar to 1 over sine squared of x. So simplifying this to make it one fraction, you're going to get the common denominator is cos squared of x sine squared of x, which is here. So if you simplify, you're ultimately going to get sine squared of x plus cos squared of x. But remember, sine squared of x plus cos squared of x, it's a standard identity. It's equal to 1. That is why we now have got 1 here over cos squared of x sine squared of x. So now you get back to say, okay, fine, what is it that I'm supposed to get ultimately? You're ultimately supposed to get cos sec squared of x sec squared of x. But 1 over cos squared of x, right? Sine squared of x is similar to 1 over cos squared of x. You can just split it, multiply by 1 over sine squared of x, right? So 1 over cos squared of x has got a standard identity, which is cos sec, sec squared of x, right? 1 over sine squared x has got a standard identity, which is cos sec squared of x. So it means that you have proven that the left hand side is equal to the right hand side. I think it's quite straightforward. Let's do another example again. So this time around, I've got 1 plus sine of x over cos of x plus cos of x over 1 plus sine of x is equal to 2 over cos of x, right? So right now, you have got the simpler form that I've advised you first of all to say, make sure that you put your right hand side into simpler forms, either with tan, cos, or with sine, right? So already you have got that on the right hand side here. So it's basically an issue of making the right hand side a single fraction. So you're going to do that how? Cos squared, cos x multiplied by 1 plus sine of x in brackets. Then you divide. Ultimately, you're going to get 1 plus sine of x multiplied by 1 plus sine of x plus cos x multiplied by cos of x, right? Then you expand and remove this bracket here. You're going to get 1 plus sine of x plus sine of x plus sine of squared of x plus cos squared of x. Then 1 plus sine of x plus sine of x, you're going to get sine, 2 sine of x plus sine squared of x plus cos squared of x. This one here is got a standard identity, which is 1. That is why we now have 1 here. So it's now 1 plus 1, you're going to get a 2, right? So ultimately, you're going to get 2 plus 2 sine of x, right? Then you've got a common factor, which is 2. So you can factor out 2 here, and you're going to be left with 1 plus sine of x, right? So you also have 1 plus sine of x on the numerator. So it means this one and this one will cancel out. And you're left with 2 cos of x. And ultimately, you wanted to get to 2 cos of x. And now you've just arrived. Meaning saying your left hand side is equal to your right hand side. And you've proven the identity. So, ladies and gentlemen, let me re-emphasize this. It's very, very important for you to get the basics of the first 2 videos, introductory videos that we did. And you've got to know the standard identities. And here is more of applying the standard identities. So take your time, get to your question, pause before you see the answer, try to work it out. Make sure that you understand, redo it until it makes sense to you. Thank you so much.